Welcome to my channel. I still remain SIR BOJ, the best tutor in the whole world, and today we'll be talking about mixtures and separation techniques. So I know that you know about matter. Matter are things that has mass and occupies space. So you know the matter exists in three major forms: as elements, as compounds, and as mixtures. All right. So we are going to be talking about mixtures into this video. All right, so what are mixtures? So mixtures contain two or more substances that are not chemically combined. All right, two substances. These substances can either be elements or compounds. All right, it can contain elements and compounds, or compounds and compounds that are not chemically combined together. They are physically combined. Are we together? And in no definite proportion. All right, so separation techniques are used to separate these mixtures, and separation techniques are physical processes. They are not chemical processes. All right, so this is important since most substances are needed in their pure form. For example, you have soil, you're going to see sand there, you're going to see sticks. All right, you're going to see insects, you're going to see probably, droppings of animals on the soil. You're going to see plants. It's a mixture of all these things. Okay, so if you want to separate it, it will require a separation technique. Or let's say I mix rice and gari, or rice and beans together. These are two separate entities. Okay, so you can separate them. All right, so we have different scenarios in the house or in the kitchen that depicts what mixture is. All right, so I don't know if you have tried soaking gari before. Maybe you came back from school and you were very hungry. Then I'm sorry if you're not Nigerian, it's called gari in Nigeria. Then you can call it cassava flakes if you care. So you put curry, you put water, you put your granules, your sugar, you put your ice block, you put your milk, put your Milo, and all those. So this is a mixture of different substances. All right, and you can also separate them using separation techniques. Or another example, when you get water and you put salt inside and stir it, or when you bring water, you put ORS, for example in a hospital, to stop stooling and vomiting. That's for rehydration. All right, I guess many of us we have witnessed a lot of situations around us where mixtures were used. All right, okay, some of the separation techniques we'll be talking about in today's class are filtration, centrifugation, decantation, sublimation, evaporation, distillation, fractional distillation, crystallization, magnetic separation, sieving, and chromatography. So please take note of everything I'm going to be talking about, because they will be very helpful for your WAEC, NECO, and JAMB examination, because they don't miss this particular topic out. All right, so let's talk about the first one, which is filtration. All right, now filtration is the separation technique used to separate an insoluble solid from a liquid. For example, rice is not soluble in water, so you have a mixture of rice inside the water. For it to separate it, you are going to filter the rice. Are we together? Now many African mothers, they'll be like, get a sieve, let's sieve this rice. It's very, very wrong. You don't sieve the rice, you filter the rice, because the rice is not soluble in the liquid. All right, so what happens in filtering or filtration is that you put a filter paper, something like this, okay, you can see that diagram. Okay, so the first aspect is where you have a beaker containing a mixture, let's say chalk particles and water, or rice and water. Then you put a filter paper into the funnel, okay. Then you put it inside a conical flask. Then the solid mixture stays on top while the filtrate goes down. So that's what filtration is all about. So next we're going to talk about centrifugation. So in your exam they can ask you a question: which separation technique is used to separate insoluble solids from liquids? All right, the answer is what? Filtration, using a filter paper, any other apparatus. So when we talk about centrifugation, it is used to separate tiny solid particles that has different densities by spinning them in solution around an axis at a high speed. All right. So in the laboratory, in most secondary school laboratories, I'm not sure they have centrifuges, but in university, if you're gonna be studying courses like medical laboratory science, medicine and surgery physiology, you're gonna be seeing a centrifuge, and it's popularly used for separating blood components. All right, because blood components are solids. The red blood cells, white blood cells, platelets, they are solid particles. So for you to separate them from the liquid, which is plasma, you're going to use centrifugation. Okay, let me show you the picture of a centrifuge. I think that would be helpful. In each of the centrifuge, there is a test tube. You can see the test tubes. All right, you can see the test tubes. You can see the test tubes. Okay, so this will spin the test tube that the components will now separate according to their densities. So the more dense will separate. All right, according to their densities, you see them in layers. You can now easily extract anyone that you want. Do you understand? Okay, so that is that for centrifugation. So it is popularly used for separating blood components in hospitals. So in JAMB they can ask you which of these separation techniques is used for separating blood components. The answer is what? Centrifugation. Okay, now the next is decantation. Now let's say I have a cup of dirty water, and the popular practice is that I will allow the water particles to separate. All right, the clear water will come up while the water particles will go down. All right, just allow it to settle down. Then you now pour out the clear parts into another clean container. This is what decantation is all about. Okay, let me show you a picture, a good exemplification. This is a liquid containing undissolved solids. Okay, this is the first beaker. It contains undissolved particles here. All right, so you pour out the clear liquid into another beaker. So here you have a clearer liquid. All right, so that is what decantation. Are we together? Okay, so we have sedimentation. The next, it is a technique used to separate heavier impurities present in liquids. Okay, so the heavier impurities present in the liquid, such as water, settles down at the bottom of the container sometimes. So sedimentation is not useful for lighter impurities, and it takes some time for impurities to settle. Okay, so we have separating funnel. I think I will need to explain this very well. So separating funnel is used for separating immiscible liquids. All right, there are some liquids that don't mix together. For example, oil and water. I'm not in the laboratory, so I can't exemplify this, but I'm going to give you some pictures that will be very helpful. Immiscible liquids, they don't mix together. Oil and water, they do not mix together. What usually happens is that the oil will come up because water is more dense than oil, so the oil will come up. Are we together? So what you now do is to tap off the water, because the water is down. You now on the tap, the water will run off, will run out, then the oil will remain. Okay, let me show you a diagram. me show you a diagram. So this is the separating funnel. All right, this is a separating funnel. So this is a mixture of kerosene and water. Kerosene and water. All right, and this is the tap, and this is the beaker for collecting the pure sample of water. So the experience is that kerosene is lighter than water, so water will go down, all right, while kerosene will be on top. Okay, so when you remove this, when you open the tap, the water will run out, then it will not remain the kerosene. So in JAMB they can ask you which of these is used for separating immiscible liquids. The answer is what? Separating funnel. Are we together? So the next separation technique we are going to be talking about is magnetic separation. This one is very, very simple. Let's say we have magnetic substances and non-magnetic substances. For example, iron fillings with plastics. So what we're going to do is just to bring a magnet and put it on top. Then the magnetic substance will join to the magnet, leaving the non-magnetic substances. All right. So I think that is very, very relatable if you have used the magnet before. Then the next one is sieving. So sieving is used for separating solids of different sizes. Solids of different sizes. Okay, let's say stones and rice. You can use a sieve, okay, to just shake it. Then the rice will go down while the stones will be on top, because the stones can't pass through the sieve because they have different sizes. Are we together? Yeah. So sieving is used to separate gold and diamond in mines, okay, and in flour mills to separate impurities from wheat. Impurities will be in the sieve while the wheat will go down. So the next one is crystallization. Okay, we're going to talk about crystallization, then fractional crystallization. Now crystallization is used to obtain pure crystals of salt, okay, which decompose easily on heating from its solution. Listen, pure crystals of salt which decompose easily on heating from its solution. So the impure solid is dissolved in a solvent, then the solution is heated to evaporate most of the solvent, then the hot solution is filtered and allowed to cool. Then after some time, the pure salt crystals forms in the solution. Then the crystals are collected and allowed to dry. So it's the means of obtaining salts, okay, and even sugars. Now fractional crystallization is used to separate two or more solutes, that's solids, that are present in the same solution. Two or more solids that are present in the same solution. Let's say we have stones and sugar inside a solution. How do you separate it? Fractional crystallization, okay. But the solutions that are to be separated must have different solubilities and at different temperatures. These are the criteria. They must have different solubilities and different temperatures. So starting from a particular temperature, as cooling of the solution of those solutes take place, the crystals of the relevant solutes appear, leaving the other solutes in the solution. Then crystallization is used in industries where the purity of the product is important, where we need to obtain pure samples of this particular product or the crystals, okay. For example, in drug industries and sugar industries. All right, so we need fractional crystallization. Whenever you hear fractional crystallization, fractional distillation, anything fractional, it means that we have two or more substances. All right, yeah. So let's talk about evaporation or evaporation to dryness. Let's say we have a mixture of sugar and water. You just put it in an evaporating dish and heat, and when you heat it, the water will evaporate, leaving the salt or the sugar particles. All right, so let me give you a diagram to explain that. This is a mixture of salt and water, and the mixture of salt and water is called brine. So you put it in an evaporating dish, then heat. The water will evaporate. And what is evaporation? The disappearance of water into the air. All right, then the solutes or the solid particle will remain. Are we together? So that is evaporation. Are you learning something? Now in sublimation, what is sublimation? It's the change of state from solid to gas without passing through the liquid phase. All right, can you name some substances that change from solid to gas without passing through the liquid? I guess you are thinking of substances like air freshener, camphor, amino sulfate, and the rest. Okay, now when you have substances that can sublime and substances that cannot sublime, and you heat, what happens is that the solid changes to gas, while those that cannot sublime, they will remain. So that is sublimation for us. Okay, now the next one, distillation. What is distillation? So distillation is an effective method used to separate a mixture that consists of two or more pure or miscible liquid. They can mix together. All right, so any liquid that can mix together, two or more liquids that can mix together, we use what? Distillation. Okay, so this is a process where the components of a liquid mixture are heated to vaporization based on the different boiling point of the constituents. Okay, so the process is that the vapor passes through a cooled tube called a condenser, where it condenses back into the liquid state. Now the condensate that is collected is called the distillate. Then distillation can be used to separate a mixture of ethanol and water, because ethanol and water, they can mix together. All right, so you can use this particular method of distillation to separate them. So we now come to fractional distillation. Now fractional distillation, remember that I told you about fractional? It means there are now many things, okay, and temperature is strictly involved. So it is used to separate mixtures of two or more miscible liquid based on their boiling point. They have different boiling points. For example, petrol, kerosene, gas, all those things, they are all mixed together in crude oil. All right, and they are mixed together. Okay, so how do you separate them? By fractional distillation. So the process you see in refineries, okay, is simply fractional distillation. At different temperatures, each of these constituents or distillates are removed. Okay, so at a definite temperature, kerosene is removed. At a definite temperature, petrol is removed. At a definite temperature, natural gas is removed, and all that. It is also used for separating the constituents of air. Do you know that the air we breathe is a mixture of gases? So there are gases like nitrogen, oxygen. So for you to separate these particular gases, it is at a definite temperature. That is what fractional distillation is all about. Now let's talk about handpicking. Now, have you tried picking beans before? In most African homes, before you cook beans, you have to hand pick, because the beans usually comes with a pod and stone particles, so you have to hand pick the beans and leave out other aspects. Do you understand? So that is what hand picking is all about. So it means picking out all the unwanted substances by hand, and now leaving the wanted particles only. All right, so I'm sure this video class will help you a lot, especially in preparation for your exams like WAEC and NICO and JAMB. So do well to subscribe to this channel and get ready for more videos. Okay, so I'm going to do past question analysis on this particular topic, so get notified by subscribing to my channel and anticipate. Thank you for joining today's class. Bye.